All right. So today we are going to discuss a bit about the details of the descriptives that we introduced in the last session. I hope that the participants watched the video of the last session and they got a bit of an idea about what the common descriptives for data analysis are, as well as how to do them a bit on Jamovi and Excel. Today I'm going to elaborate on both of them a little bit more than the last time. Okay. So let's just get on with it. I'll share my screen now. Okay. So 1 minute. Yeah. So the last time we discussed that whenever you have a large data series, at that point of time, you are hard pressed to describe the data to the viewer or the reviewer in front of you in the form of the data series itself, right? Because it's like a large data series. You cannot really describe it in any way apart from providing summarization measures. So the most common ways of summarizing a data are to provide some idea about the middle point of the data. That middle point of the data can be by various means that we'll talk about, and how the data is distributed around the middle point. These are called measures of dispersion. So you have got measures of central tendency, which are the middle points, and you have got the measures of dispersion, which are on the sides. Okay. Now there are broadly three measures of central tendency, that is mean, median, and mode. And I'll be describing mean and median mostly because mode is practically not much used. Like at least in my career as a data analyst, I have not really used mode in any significant way. It may be used for some nominal variables, but mostly for quantitative variables, it's not very useful. Okay. So at the outset, I'll just tell you that mean is useful when you have got actual numeric data. Okay, numeric data which can be expressed as integers or as decimals. Okay, and in which you have got the difference between the levels is fixed, like the interval scale that we talked about in the last video. If the data is ordinal type, meaning that the difference between the levels is not fixed, then we go for medians. There are a few other caveats to using mean and median appropriately, and I'll talk about them as I go through this video. So first, let's talk about the mean. Okay, so I think most of us are aware of what the mean is in context of data analysis. However, one thing that you may not know is that there are multiple different types of means, okay, which are useful for different scenarios. So here I'll be talking exclusively about the arithmetic mean that most of us know as the average of numbers. Okay. So I think I don't need to repeat the formula for it. Like it is basically add up all of the data series and divided by the number of items in that data series. Okay, so it is basically written in this complex fashion, but I know that most of us get offended when we look at this type of notation because it doesn't make much sense to us. But believe me, it's not that difficult to read once you get used to it. So it is basically 1 by n, that is the 1 by the number of samples that we have in our data series, multiplied by, this is called a summation mark. Okay, so this is basically capital epsilon. So this is basically your summation of xi, that is I is the data series, xi is each item of the data series, which will go from x1 to xn. Okay. And these two notations basically means that the data series starts from I equal to 1 and ends in I equal to n. Okay, so xi, in which I is starting from 1 and ending in n, you add up all of those and you divide that by n. Okay, so this is like the mathematical notation of how to do mean. So here I've got a pictographic representation in which basically you have got the data series. All of these tiny blobs are data series. The size of the blobs is basically the magnitude of each data item. Okay. And the star in between is the central tendency here, that is the mean. Okay, so arrows basically represent the contribution of each of these to the mean, meaning that the tiny ones, they will contribute less, hence the thinner arrows, and the fatter ones, that is the higher magnitude items, will contribute more to the mean. That is why they have got thicker arrows. Okay, so this is in this pictographic representation, you will immediately understand that if you have got too small or too large values in your data series, then your mean gets pulled towards that, because the mean gets inordinately affected by outliers, whether they are too low or if they are too high. Like if most of your data series ranges from suppose 10 to 100, okay, and you have got one data point which is 0.001. Okay, maybe it's a typographical error, maybe it is just an outlier, whatever you call it, but your mean will be affected by that, and your mean will get pulled towards the lower end of the range. Okay. Similarly, if your data series is from 1 to 10 and you have got an outlier which is like on the higher side, which is like 1,000, okay, your mean will get pulled towards that higher number. And most likely in this case, your mean will be somewhere beyond 10 even, like it can be even 50 or 60 or something like that, when most of your data series is between 1 to 10, right? So that is why whenever you have got outliers in your data, okay, and uh, then mean is not a good idea. Okay. The second point is if your data series is skewed. Okay, now let's just define what skew means. So here we can see that this is like a frequency histogram of a data series. So this is one way of representing a data series in which you have got the actual numerical values along the x-axis and the number of samples with that corresponding value on the y-axis. Okay, so basically if this is this data series here, suppose it is 1, then 1 has got a smaller number, 2 has a little larger number, 3 has a little larger number, and you see it will increase and then it will come down, meaning that the largest numbers also have smaller representations, while the smallest numbers also have small representations. Okay, less number of representations. And the largest number of representations will be for somewhere of the middle value. Now, this type of presentation is there for most data that you will be collecting. Like mostly the middle values will be the largest in number. And by definition, outliers mean outliers, like they will be lesser in number, right? But having said that, in this, you are having a peak which is exactly in the middle, meaning that the middlemost value has the largest number of samples. Okay. So in this type of case, mean can easily be used for representing the central tendency of the data. However, if you have got a larger number of outliers in either of the sides, okay, meaning that you have got a larger number of people with high values or lesser or larger number of values with less magnitude or less values, then basically the data is skewed. Okay. So that lends itself to this type of shape in which there is a hump with a tail. Okay. Now, in this case, when we talk about skew, okay, like most of us, whenever we have to describe a skewed data, in our mind, somehow psychologically, we start thinking that the peak basically represents the skew, because peak is the most important part of the graph, right? But actually, your skew is defined by the tail. So this is basically a positive skew or a right skew. And this is a negative skew or a left skew. So basically skew is defined by the side that the tail is in. Just remember that. Okay. So whenever your data is skewed, at that point of time, you will see that the mean will be pulled towards the direction of the skew, because now you have got outliers which are larger in number. Okay. So because of that, the mean will get pulled in that direction. Like in a positively skewed data, your mean will be larger than what it is supposed to be. And in a negatively skewed data, your mean is lesser than what it is supposed to be. Now, but in both of these cases, if we talk about medians, they will be more or less in the middle. And in a non-skewed data also, median will be more or less in the middle. Okay. So at least for now, understand that mean can be used. It's a wonderful way of representing the central tendency, but with certain caveats. it can only be used for numeric data, interval scale data. It should not be used for ordinal data because ordinal data itself cannot be represented as decimals. And in those cases, the mean will usually come in decimals, which doesn't make much sense. Second point, the mean cannot be used whenever your data is skewed or has big outliers. Okay, so in these cases, mean should not be used. It will misrepresent the middle point of the data. Now let's talk about the median. Okay, before we talk about the median, we should talk a bit about percentiles because this will come up when we try to describe the quartile range also, interquartile range also, which goes along with the median. So now percentiles is something that bio people have a little difficulty in understanding. So let me just clarify everything in one go. Okay. So here you have got a bunch of data, okay, in which the size of the blob basically is the magnitude of each data. Okay. So it is like a mixture of, this is, I've drawn 18 circles, that is 18 samples are there. Okay. Now, what a percentile means is that whatever value you get at whichever percentile, like suppose at 20th percentile, you get a value of 10. Okay, that tells you that 20% of your data series has values less than 10. If you have got a 99th percentile at suppose 780, for example, okay, then that tells you that 99% of the data series has values less than 780. Okay, so that is what percentile means. That is how you will interpret a percentile. Okay, now let's interpret it in terms of median and quartiles. So basically median is the 50th percentile, meaning that it's like the middlemost value. Okay. Now what that tells you is that whatever value your median is, okay, 50% of the data is less than the value of the median. Similarly, for first quartile, which is like 25th percentile, 25% of the values in the data series are lesser than the first quartile. Similarly, for 75th percentile, 75% of the data have values lesser than whatever number represents the third quartile or 75th percentile. Okay. Now, how do we go about calculating? Like, I think this much interpretation of the percentiles and quartiles and median, I guess, makes sense right now. Now let's go about how do we calculate the percentiles. First, you arrange your data series in an ascending order. So here I have arranged it in an ascending order. Okay. Now after that, if you want like the 25th percentile, okay, then P is the needed percentile, that is 25, and N is the length of data. Here it is 18 samples. Then the rank of the required percentile, okay, rank of the required percentile is rounded P into N. That is, here it is 25 into 18 divided by 100. Okay. When we do that, then the rank will come out to be 4. Okay. And the what is the fourth number? This is the fourth number, and whatever this fourth number is, this becomes your 25th percentile. So basically, you by the P into N by 100, that is the percentile you want, multiplied by the number of data in the series divided by 100, gives you the rank of the data, that is that percentile. Okay, so basically whatever your numbers are, like whether it is 1 2 3 4, whether it is 1 1 2 2 3 3 4 4, or whether it is 1 10 15 20, whatever, whatever the data series is, everything gets ranked, meaning that the difference between one and whatever the next number is doesn't have much importance. What matters is the ranking of it in the entire data series. That is why this type of representation, percentile based representation of the central tendency or the dispersion actually lets go of any of the effect of outliers or skew or anything like that. All of that basically goes out the window. What you get is uh, below this percentile, like basically whatever value this percentile has, below that, rest of the data series is lesser than that value, so on. So that way interpretation becomes much more easier. Okay. So, like in this case, we did for the P, we put it as 25, 50, and 75, and I multiplied it by 18 divided by 100. That gave me numbers of 4, 9, and 14. These are the ranks within this data series, which will correspond to 25th, 50th, and 75th percentiles. Okay, now in practice, you do not need to do this by hand. It will be automatically calculated by the software. You don't need to worry about it. Just understand what the percentile representation means. Okay, chalo. Now let's talk about the importance of median versus the mean. Now, like I said, mean cannot be used when you have got outliers, when you have got skewed data, and when you have got ordinal scale data. Median can be used when you have outliers, when you have got skewed data, when you have ordinal, as well as when you have interval scale data in whatever format it is available to you. Okay, so because of that, median basically becomes the universal way of representation of any central tendency of any data series. Okay, so that is why whenever I am doing analysis, I default to using median, because you never know which data series has got what outliers, etc., etc., and I don't want to mess around with each of the samples, each of the variables, and try to find out which one has outliers and which one do not have. It's just a severe waste of time and a lot of overhead. Just go for median and get on with it. Okay. But however, having said that, do not ignore outliers. They do definitely have some importance in your analysis. But that importance will come out later on when we do some parametric tests or stuff like that, in which the mean gets used by default. You do not have any choice in this. But at least for representation purposes, prefer the median in whatever context you use it. Okay. Next, let's talk about the dispersion measures which go along with the mean. Okay. Now, when we talked about the quartiles, one thing that you would have noticed is that the quartiles are independent of what the actual value of the data series is. Okay. What matters is just the rank within the data series. Okay. Now, because of that, what happens is that your whether the data is symmetrical or asymmetrical, that asymmetry will show up whenever you show the dispersion in form of quartiles. Okay. Now, because of that, it is universally used, but sometimes you want a little more easier to understand measure, or you want it in a format that is more required by the reader, or because they are used to that form of notation. In those type of cases, and also because you want to maybe use it in context of some probability distribution which is predefined, in those cases, knowing about the variance and the standard deviation of the data, it becomes important. Okay. Now let's describe what variance and standard deviation are. Okay. So here, in the similar fashion, I have got blobs which are in which the size of the blob represents the magnitude of the value of that sample. Okay. And in between, you have got the variance. Okay. Now, what this shows is that here you have to find the mean. Okay, calculate the mean, and then calculate the distance or the difference between each data point and the mean. Okay. Now, whenever you are calculating the difference of each data point from the mean, the negative ones, okay, the basically the ones, those data points in whom the value of the data point is less than the mean will come as negative values, and those which have got positive difference, that is the values which are more than mean, will come as positive values. Okay. Now, the easiest thing to do is that you have got these differences. Why don't we just add them up? Okay, and divide it and take an average of it, the average of the distances. Okay, now that is in technically a easy way to do it, but and this type of thing is called deviance. Okay, like whenever you are seeing just the absolute difference between the mean and each data point and summing them up and making an average of it, that is called the average deviance of the data series. However, this suffers from a significant problem, that all of those, like basically, if you have got negative numbers and positive numbers, when you add them up, obviously it's going to tend towards zero if you have got a symmetric data series, right? So because of that, to get over this, what we try to do is we add up, we for each of these differences that we found out, each of these differences that we found, we square them up, then we add up all of these squared differences and take the mean of that. Okay, so this is what variance is. Okay, so here you can see the variance, this is sigma square is variance, is defined as 1 by n, that is number of samples. Okay, and your summation of xi minus mu. Mu is your average of the data series. Xi minus mu, you square each of them, then you add them up from I equal to 1 to n. Okay, and then divide it by the number of data in the data series. Okay, so this gives you variance. Now the problem with variance is that because it's a squared number, it is much larger than the actual units in which the data series is organized. Okay, like if your data series is beat per minute, suppose heart rate, then whatever variance you're getting is heart rate squared, that is the beat per minute squared. Okay, now that can be a large number and becomes a little difficult to interpret. So an easier thing to do is you just square root it. So when you square root it, then basically your units come in the range of what your data series is supposed to be, has already. Okay, and it becomes much more easier to interpret. Now basically the standard deviation is in the units of whatever the mean is. Okay, so this way it becomes easier to interpret. So that's why whenever we are showing measures of dispersion for data which is symmetric and interval scaled, we tend to go for standard deviation. So usually notation is mean plus minus standard deviation. That is how we denote it. Okay, so again, I'll read out just to reiterate and summarize. The variance is the average squared distance of each data point from the mean. I think makes sense now. And standard deviation is just square root of the variance. Okay. So again, the caveats that apply with the mean also apply here, meaning that if you have got outliers in the data, your standard deviation will be impossibly large. And the problem with standard deviation is because it is going to be symmetric in both sides of the mean. Like if your data series was like suppose 1 to 10 with a outlier of 1000, then basically the standard deviation will go somewhere in plus hundreds and minus hundreds. You understand? So because of that, it becomes quite difficult to interpret and like actually is not a good way to represent the dispersion because you are going outside the range that the data series is actually supposed to be. So because of that, whenever you have got outliers, whenever you have got ordinal data, whenever you have got skewed data, okay, remember that skewed data also presents the same problem, like standard deviation will be large on the side of the skew and will be represented as the same large standard deviation on the other side of the mean in which there is no skew. Right. So because of that, your standard deviation overall dispersion basically becomes a large number. Okay. And the values that you get after plus minus standard deviation from the mean are impossibly large or small numbers. So because of that, for skewed data, for data with outliers, or for ordinal scale data, please do not go for standard deviation or mean. Just go for median and interquartile range. They make much more sense. So I think with this we have covered the most common ways of representing the descriptives of data. Okay. So now I'll just give you a brief idea about how to do these descriptives in Excel. These can be very easily done in Excel. Okay, but mostly you won't be ending up doing it in Excel. You'll most likely do it in some statistical software. Okay, but I'll still show you how to do it. Okay, so whenever you want to do some sort of analysis or want to do any operations within Excel, okay, you always have to write a formula within a cell. Okay, now what is a formula? Formula is basically a function. Function meaning that it is a phrase or a word which is programmed to do something. Okay, that is what a function is. Okay, now for that phrase or the word to do something, it needs some arguments, meaning that you need to provide it something to do do that function on. Okay, and that is known as an argument. So every function will have some arguments which are pre-coded, and you will have to adhere to those when you are making your formulas. Okay, whenever you are putting any formulas in Excel, always it will start with equal to. Okay. If you're not putting equal to, Excel will just assume that you are inputting data into a cell and just leave it at that. It will not do anything with it except display it within that cell. Okay. When you are writing it with equal to, basically whenever you start writing something in an Excel cell with an equal to, that means that you are basically putting in a formula and Excel is supposed to do something after that. Okay. So for mean, the function is average equal to average. In the bracket, you basically put the data series. Okay, here A basically is the column number, and 2 or 33 here is the row number. So basically A2, basically within the column A, from 2 to 33 number rows, that is the data series that you are inputting into the as an argument for the function average, and this will produce the mean for you. Okay. Similarly, for standard deviation, the function is stdev. For 50th percentile or median, your function is median. For mode, it is mode. For quartiles, you have got two arguments that you need to provide. First argument is the data series, and the second argument is the which quartile you want. Okay, so like you want first quartile, second quartile, or third quartile. Okay, and that these two arguments within the function are separated by a comma. So how it will be equal to quartile A2 to A33. This is your data series, comma which quartile you want. I want the first quartile, so 1. Okay, so I'll be getting the 25th percentile or the first quartile using this, and third quartile equal to quartile A2 to A33, comma 3. Okay, in brackets. So this basically gives you the third quartile. Okay, whenever you have done this and press enter, automatically the thing will be calculated and the number will come inside the cell where you have inputted the formula. Okay, for variance, it is var and the data series. Okay, now I won't be talking about standard error because standard error is not technically a measure of dispersion or sort of descriptive statistics. It's for other purposes, and I will explain those purposes later on when we take hypothesis testing videos. Okay. Now let me just show how it is done in an Excel file. Now here we have got the data that I have shown you before also. You have got serial number group, grouping variable, then you have got age, ASA, and hemoglobin, T1 lab values, urea at T1, creatinine at T1, so on and so forth. So these are basically numeric values. All of these are numeric values. This is an ordinal scale. Okay. Now, how do you go about doing the putting it in is like for mean, you have to, in this, it won't be visible very nicely, but if you can see at the top, okay. So for 1 minute. So at the top, you can see this is how I have put it. Equal to average for the mean, equal to average. As soon as you start writing like D2 is to D9, you can either write out D2 is to D9. Here it is like the D column, second row is to 29th row. Okay. So this basically, or you can also do, like I'll redo it here. So equal to average in bracket. And after that, all you need to do is just drag your mouse across the, like click and drag across the data series. Okay, whichever numbers you want to be inputted into it, and then press enter. Okay, so this way you have calculated the average of age. Now, once you have calculated the average of one column, okay, and you want to apply the same formula to the nearby columns, all you need to do is hold the corner and drag. Okay. And you will get it. So suppose I did not have anything inputted in all of these and I wanted average of all of these columns. Okay. I've already made the formula for average here. Okay. And after that, I will drag hold in the corner and drag it across till the end, and automatically the averages get calculated. Okay. Now with dragging, what it is accomplishing is, see here, you can see here the column number has changed. Earlier it was D, now it is E. In this one, it is F. In this one, it is G. So basically by dragging, the Excel will automatically change the column number and will apply the formula to that column. Okay. Similarly, for standard deviation, it is stdev D2 to D29 and so on, and I have dragged it across. Similarly, for first quartile, you can see the formula is equal to quartile D2 to D29, comma 1. Okay. And you will be getting the first quartile, and then you'll be getting the third quartile, and you can just drag it across and you will get it. Okay. Now, so this is how you do it in Excel. So basically, if you have got any columns that you want to get descriptives for, okay, and they are organized in parallel columns, or you can maybe organize them in parallel columns. Then you just do this type of write the formula, drag it across, and you get the mean, standard deviation, or median, interquartile range, whatever you want. Okay. This is how you do it in Excel. Now let's do it in Jamovi. Now Jamovi fortunately has a much more easier to use system, of course. So here, what we'll be doing, the same data has been inputted into this one also, in Jamovi also. Now, one thing with Excel is that when you try to do it for the overall data, it is good enough. But when you want to do it with multiple groups, okay, then you have the hassle of arranging the data by the group, and then making space between the groups for, like, you have to insert rows between the groups for making some space, and there you will be inputting the formulas and so on and so forth. So it becomes a hassle-prone process when you have got a group-based descriptives in Excel. So that is why in these point-and-click statistical softwares, it's much more easier. So what you need to do is this. So go to descriptives. Okay, so when you open the descriptives, then you will basically have all the variables on one side, and you have got variables and split by. So split by is basically a grouping variable across which you want to split all your entire data set, and it will analyze the descriptives for each of the variables that you need. Okay, so here group is the split by, so I'm putting it here. And then for all of the data except for sex, I want the descriptives. Okay, so here I'm highlighting all of them, and I'll remove the sex because that's a nominal variable. So I've put it in, and you can see that automatically it is calculating the descriptives. Okay. Now the thing is that we do not want many of the descriptives that are given here, and like minimum and maximum, and we are not getting any quartiles here. So I want the quartiles, right? So for that, what you need to do is you press the statistics tab here. In that, we do not want the number of patients or number of missing values. If you want it, you can retain it, but I don't need it right now. So I'm going to untick these boxes. Now automatically these get removed. I also do not want minimum maximum. So they will also automatically get removed. Here I see that there is a percentiles tab. Okay, in which 25th, 50th, and 75th percentiles are automatically there. So then I do not need the median because median is the 50th percentile. So I'll uncheck the median and I'll check the percentiles. Okay. So now it is calculating and it will come shortly. Okay. Now, along with this, there are quite a few other good functionalities which are there in Jamovi. Like it can easily help you calculate the skewness, kurtosis of your each of the data. It can also do a normality testing using Shapiro-Wilk test. Okay, so in normality testing, in all of the normality tests, whichever are there, I think there are uh, uh, three common ones. The most common ones are Shapiro-Wilk and Kolmogorov-Smirnov test. There's one more, I think, Anderson test. Okay, so these three are the most common ones in which your Shapiro-Wilk is less conservative. That is, like, if the data is not normally distributed, also sometimes it will give it as normally distributed. Kolmogorov-Smirnov is a little more conservative, and this Anderson is somewhere in between. So most people prefer that Anderson one. I'm not able to find the Anderson. I'll show it to you later on if I can find it. It is there in this. Then, but mostly in most of the papers, you will see Shapiro-Wilk being used or Kolmogorov-Smirnov being used. And how to interpret it is you just check this Shapiro-Wilk one. Now it is calculating. So in this, basically within group A and B, it has calculated the p-values for the Shapiro-Wilk test. So Shapiro-Wilk W is basically the statistic or the estimate that has been produced. Okay, you don't need to bother with that. You just need to bother with the p-value, that is the Shapiro-Wilk p. If it is less than 0.05, that means that the data is not normally distributed. That's all. Like in ASA, A and B, both of the groups, it is not normally distributed. HBT1 lab, in group A, it is not normally distributed. Group B, it is normally distributed. And similar pattern in HBT2 HemoQ also. And rest, everything else is normally distributed. Okay. So I'm going to uncheck this because I do not need this right now. So these are the descriptives that you commonly need: mean, standard deviation, and the percent quartiles. Okay. Now, how do you use this for your purposes? You will right click on this, copy it. You will open a fresh Excel file. I'll open a fresh Excel file. Okay. And I'll paste the data. Okay. Now, once I have copied and pasted the results, now you can see that how it is organized is in a beautiful table-like fashion, but practically when you do it for publications, you will not be putting it in this fashion, right? So I'll give you some tips and tricks on how to organize this into a beautiful table. Okay. First thing is you will notice that these tabs, these cells basically are merged. So first we have to unmerge the cells. Okay. After you have unmerged the cells on any one of this, okay, like in the mean one, suppose you will be highlighting the row. After you have highlighted the mean row, you do control plus G. Okay, that will open the go to function. Okay, in go to you will open the special. In special, you will click on blanks and press OK. Now you are seeing that the blank cells, whichever are the cells which are empty, have been automatically highlighted. Now, once these are highlighted, we can go to delete tab here and select delete sheet columns. Okay, so basically whichever are the highlighted tabs, based on them, the columns will get deleted. And now you have got the table which is beautifully represented here. Now, this is also not as useful for you because you still want mean plus minus standard deviation or median bracket interquartile range, right? Now, how you will be doing that is by using a magical function like this one function that I have used the maximum, I think, in Excel since I started doing data analysis. That is concatenate. Okay, equal to concatenate. Okay. Now, once you have written this, after this, suppose, okay, I want median and interquartile range for group 1 and group B respectively. Okay. Now, the 50th percentile is the median and these two are the quartiles. So, I'll be selecting group A first. Okay. So, concatenate equal to concatenate. How concatenate works is that you will highlight whichever cells you want. Like I want the median. Okay. So this is the first item that I want to put into the phrase that I'm making. Okay. So what concatenate does, let me just explain first. What concatenate does is that you have got disparate cells or some fixed values that you want in a phrase. Like you have got multiple words, you want to join them into a sentence. Okay. So concatenate does all of that automatically for you. Okay. So here the way I want it to be represented is median space bracket start quartile 1. Okay. Then maybe a space hyphen space quartile 3 and then bracket close. Okay, so if I want it to be represented in this fashion, how I'll be writing is concatenate E10 because that's the median. Okay, comma. Each of these words within the phrase, you can call it, will be separated by a comma. Next, I want a space and a open parenthesis. So I'll start with a quotation. But whenever you are making fixed notations, like fixed values within the phrase, it has to be within quotations. So quotation, space, and bracket start. Okay. Then quotation close, comma. Next, what I want is the first quartile. So I'll select out the first quartile, comma. Now I want space hyphen space. So quotation start, space, hyphen, space, quotation close, again, comma. I'm separating out each of the words of the phrase. And then this 75th percentile. Okay. Then, comma. Now I want closing brackets. So closing bracket within the within quotations. And then I am done. Okay. So now it automatically comes like this. Now, why am I doing it like this? Because I want to be able to drag it across. Okay, so this is not required. So basically now you saw that automatically all of these like 38.5, 30.8 to 52.3, then 2 is to 2, then 13.9, 11.8 to 14.4. So it got automatically populated here. Okay. Now so this is for the A. Now I want the same thing for the B also. Now here I can see that your uh, A is, so basically B is directly below A. So if I just pull this down, 41.5, 32.3 to 44.45, right? And then I'm going to just drag this across also. And I'm done with the B column also. Now that I have made these, what I'll do is I'll take all the variable names, copy variable names here. I'll be putting the group A and group B. Okay, so now I have got this table ready, but now the thing to remember is that now all of these are still in their formulaic forms, right? Like the cell, if you click on any of the cells, it is going to show a formula. Okay, and what is the point of a formula? If you move the formula from cell to cell, values will change. So basically, if you copy this table and paste it anywhere else in the Excel, it is going to try and refer it to try and get values from the referred cell within the formula. Okay, like which will be in relation to the current cell that it has been placed in. You do not want that. So what we'll be doing is we'll be copying this entire thing and then pasting it as values. So paste values. You can see this. I've pasted values, and now if you click on any of the cells, it is just showing the value within it. That's all. Okay. Now, because this is not how we usually represent, what I'm again going to do is I'm going to copy and paste it as a transpose. Okay. And I'm done. So here you can see that now I have got a beautiful table in which I've got group A, age, ASA, this, and group B, age, ASA, this, as nice descriptives, and my table is ready. Okay, now I can, like most of you will be thinking there's a lot of steps, but practically speaking, this is much more easier than copying and pasting each of the numbers and putting brackets, putting hyphens, so on and so forth. Once you get the hang of it, it happens like that. Okay, so I would suggest that you practice this in your free time. Making tables becomes very easy. It doesn't matter how many variables you have, everything gets finished off in a formula. Like giant tables of thousands of variables, you do it like this. You understand? Now, let me show you again as a practice for how to do it for mean plus minus standard deviation. Now, you have to understand that plus minus, like how we denote it as mean space plus minus space standard deviation. Now, the problem with plus minus is that it has to be inserted separately. So, you have to insert it beforehand. From the insert tab, within that, you have got the symbol. In the symbol, you will be pressing the plus minus, insert, close. Okay, so now I've got the plus minus inserted. Now I'm going to just cut it. Cut means or copy it, whatever you want. Okay, so now it is copied onto the clipboard of Excel. Okay, now again we'll start with equal to concatenate bracket start. Okay, here let's start with group A. So I'll be taking mean, that is mean age E4. Okay, comma, quotation start, space, paste the plus minus, space, quotation close, comma, and I want the standard deviation of the corresponding variable of group A. Okay, and I'm done. Now, once I've done this, I'm similarly going to drag it across and I'm going to drag it below, and I've got it for group A and B. So I'm going to copy the A, B here. I'm going to copy the name of the variables here. Okay, then I'm going to copy this and paste it as a paste values. Paste values. Now I'm going to copy it again and paste it as a transpose. And we are done. You see, you saw how less time it took to make this beautiful table, right? So using this way, concatenate, basically using the concatenate appropriately, you can make tables very easily, very easily. Okay. So later on, sometime I'll show you how to do it for these nominal variables also. Right now, I'll just show you how to do nominal variables, like get the frequencies and percentages within Jamovi. Okay. So we are done with interval scale as well as ordinal variables, quantitative variables. Let's go on to qualitative variables. Okay. Now for qualitative variables in the descriptives, you can see there is an option of frequency tables here. Okay. But this is not a very great option for you because this is quite limited in its utility. I think they have made the software similar to SPSS. In SPSS also within the descriptives, like explore descriptives, your frequency tables was not very great. Okay, so to get the better frequency tables in which you have got row and column and you get percentages by row and column, these are called cross tabulations or contingency tables. So to get better contingency tables, you go to frequencies. Okay, once you click frequencies, in that you do independent samples. When you press independent samples, then you will get the option of rows, columns, and counts and layers we'll not talk about right now. Okay, so in our data, we have got broadly two nominal variables. One is the grouping variable that we want as rows, and we have got sex, which is the only other qualitative variable or nominal variable. So we'll put it as columns. Okay, so as soon as you put it, what happens is that it will give you a frequency table right here. Okay. Now you can see that it has given you a frequency table in which in group A there is 7 females and 7 males. In group B there is 5 females and 9 males, but it is not giving you the percentages. So for getting the percentages, you will click on the cells tab. In the cells tab, you want percentages by row or by column. You can do it either way. So how to interpret it will be like if you do it by row percentages, then basically in group A, how many percent were females, how many percent were males. Okay. If you do it by column, what you will be getting is in females, how many percent were group A and how many percent were group B. Okay. So in whenever you are doing it by column, the sum of the percentages here will add up to 100. Sum of percentages here will add up to 100. If you do it by row, sum of percentages here will add up to 100 and sum of percentages here will add up to 100. So mostly what we want is within each group, how is the frequency distribution of the levels of the nominal variable. So we'll be pressing row, and in this, within the row, this 50%, 50% adding up to 100%, and within B, you've got 35.7% as females and 64.3% as males, adding up to 100%. So this is the table that you want. Okay. Along with that, it also gives you the chi-square test that we'll be talking about in some future video. But yeah, this is how you get it. Now, what you can do once you have done this is copy this. Let's try to make a table of this, but actually making a table of this will be much more better if I do it for multiple qualitative variables. And I think I'll show it to you later on when I actually discuss the nominal variables analysis, that is chi-square test, Fisher exact test, and all of that, the hypothesis testing. Along with that, I'll show you how to do the tabling for contingency tables or nominal variables. Okay. So I think with this, we are done with the descriptives, detailed descriptives portion of the video of the entire course. So I hope this was useful for you, and I hope that you will be able to do this on your own whenever you do it. Remember, in statistics, everything is practice, practice, practice. Okay, I also learned all of this by practicing throughout the last 10 years, and slowly, slowly, I've picked up a lot of tips and tricks that I'm trying to provide to you right now via these videos. Okay, so I hope this was useful, and have a good day.